Hi guys, today what we're going to do is going to look at what's called conditional probability. And you can see here from the blurb it says this is probably an event may change if we know that another event has occurred. For example, it says show that a fair die is thrown and we know that an even number has appeared. What is the probability that the number obtained is less than 4? So what we have here is we've been given extra information. We've been told that it's an even number, which therefore now is limiting our sample space. And I'll show you what I mean by that in a diagram in a second. Okay, so let's just look at the mechanics of this, and what we have here is how we're going to write this. So if we let A be the event that we know has occurred, i.e. that an even number has appeared, and B be the event that the number attained is less than 4, then we want to find the probability of B given that A has occurred. And the way we write this is the probability that event B given that A has already happened. So for this particular example, it's the probability that it's less than 4 given, this is what this line means, given that we already know that an even number has appeared. And as I said, this is called conditional probability, because the fact is the probability of B occurring is conditional on the fact that A has already occurred. So I'm just going to put this information into a Venn diagram and then we'll look at it in that way. So the Venn diagram's been drawn, as you can see here, and as we said, A is the even numbers. So you can see in my set A here I have 2, 4 and 6, and the event B is less than 4. So we've got 1, 2, 3 and 5 isn't part of any of these two sets, it lies outside of A and B. Now what we're trying to work out is the following. So it says it's the probability of B given A. Now if we know A has already occurred, then what we are doing is we are essentially just shrinking this sample space. At the moment what we have is we have the whole sample space here, and we can say that the probabilities are all worked out from here. But because we know that A has already happened, instead of looking at this whole sample space, what we're doing is we're reducing it to just the sample space of A to work with. So that's what we're dealing with now, that sample space there. We know that it's an even number that's occurred already. We already know that, so we don't really care about this 1, 3 and 5 here. So instead of having a sample space of 6 numbers, I've now reduced it to just these 3 numbers in A. My event B is that the number is less than 4. Okay, so what we can see here that the number less than 4 is this 2 here, because 2 is less than 4, 4 isn't less than 4, and obviously 6 isn't less than 4. So you can see here that it's the intersection. So that's going to be important. It's always going to be the intersection of A and B. And you can see here that instead of now being out of the whole of the 6, we've got 3, which is essentially the number in set A. So what we can do is we can write this now as a definition and say that this is equal to the number of A intersection B, or B intersection A, it's the same thing, over the number in A. So you can see here, just to show you, remember that is the same as hash R over hash N, and then we can work out the probability. So how many do we have in the intersection? Well, you can see here there's 1, it's the 2 in the intersection, so that's equal to 1. And in A altogether we have 1, 2, 3, so the probability is a third. So just to recap the last slide, what we have here is just a formal definition, and it says if A and B are 2 events, probability B of A stands for the probability given that A has already occurred. This is given by, as you can see what we did in the previous one, it's just put into words for you, and again, sample space equal likely, we also have this definition here. It's exactly the same thing. Now the way to remember which one's which, guys, if you have the probability of B given A, a lot of people will forget which one goes underneath. It's very, very straightforward. It's always the intersection of them, so you can write this as B intersection A, and then whatever this last one is what goes on underneath. Okay, so whichever the last one is, that's the one that goes underneath on the fraction. Okay, let's have a look at an example. So it says in a certain college, 25% of students failed maths, 15% of students failed chemistry, and 10% failed both maths and chemistry. Student is selected at random. Find the probability that the student failed maths. P of M here. Well, it says 25% of students failed maths, so this shouldn't be too hard. So P of M is equal to 0.25, or 25 over 100, which is a quarter, or 25%, but we'd rather keep it in terms of decimals or fractions. Okay, the second part says find the probability of C given M, the probability the student failed chemistry given that he or she failed maths. So we already know that they failed maths, guys, which is important. So this is equal to the probability of the intersection. And as I said in the last slide, all we do then is we bring this second one down, and that's the one that goes on the bottom, and just stick the numbers in. So it's the probability of C intersection M. We're told that 10% of students failed both maths and chemistry, and 10% is 0.1, divided by the probability that they failed maths. Well, we already know that, that's 0.25. And if we put that into a calculator, what we get is 2/5, which is equal to 0.4. Okay, so that's just using the formula there. That shouldn't be too difficult. Let's have a look at another example. 3 cards are chosen at random from a standard pack of 52 cards. What's the probability that all 3 cards chosen are club, given that exactly 2 of the chosen cards are known to be picture cards, and they've defined a picture card here as Jack, Queen, or King. So the first thing we need to do is to define our events. So let's have a look at event A, and that is that the 3 cards chosen are clubs. So it's equal to 3 cards chosen are clubs. Event B is that exactly 2 chosen cards are pictures, so exactly 2 cards are picture cards. Okay, the next thing we want to work out is what our conditional probability is. And it says here that it's the probability that all 3 cards chosen are clubs, given that exactly 2 of the chosen cards are known to be picture cards. So what we have here, that is the probability of A, given that we know that B has occurred. Okay, so we know that's going to be probably A intersection B over the probability of B. So now what we need to do is now we need to work out the probability of A intersection B and the probability of B. So let's do the intersection first. So we've got probability of A intersection B. So we'll do that one first. Okay, so probability of A intersection B is exactly 2 picture cards and all are clubs. So it's exactly 2 picture cards. Okay, and I'll just put all clubs here as well. So now we're going to work that out. Let's have a think about that. That means that how many picture cards do we have that are clubs? Well, we have 3, and we need to choose 2 of them. So that's the King, Queen, or Jack. So we need 2 picture cards from them, which means from the rest of the clubs, because we've now picked those 3, that means there's 10 clubs left, and we need to pick another 1 from there. So again, just to go through that, what we have is we have to pick 2 picture cards from the 3 that are available, which now means that those 3 cards are not available, and we have to pick 1 from the remaining 10 clubs, because there have to be 2 picture cards and they have to be clubs. So we can work that out. If we work that out, that's going to be 3 times 10, which is equal to 30 ways. Now let's look at working out the number of ways that we can do event B, which is the bottom of the fraction here. So what we have here is exactly 2 cards are picture cards. That shouldn't be too difficult. So probability of B, exactly 2 cards are equal to picture cards. Okay, so 2 cards are picture cards. And if you think about that one, then how many picture cards do we have in the entire deck? Well, there's a Jack, Queen, and King for every suit. So that's 3 times 4. So we're choosing from 12. And we need 2 picture cards. So that's 12, choose 2. Which means from the remaining cards, which is 40, because there's 52 cards in a deck, we need to choose 1 more card to pick the 3. If we put that into our calculator, boys, we get 2640. We then put it into the relevant formula, so the probability of A given B has occurred is equal to the probability of A intersection B over the probability of B, which is equal to 30 over 2640, which if you stick it in your calculator comes out to be 1 over 88. Now notice that I didn't have to work out the probability of event A, or the number of ways that we could do event A in order to answer this question. And hopefully guys you can see how this has been done. Now look at one more example. So here we have example 3, and what we're going to do is we're going to use what's called a tree diagram to do this. It says Kevin has reached the final of a TV game show, where's a chance of winning 100 grand. First thing he has to do is spin a wheel. This will determine which of the 3 boxes, X, Y or Z, he will open. The wheel is arranged so that the probabilities of it choosing X, Y and Z are 0.2, 0.3 and 0.5 respectively. He then has to choose a card at random. Each box has a number of winning cards and losing cards. Box X has 1 winning, 3 losing. Y, 3 winning, 1 losing, and Z has 2 winning and 3 losing cards. And given that we know that Kevin wins the 100,000 prize, what's the probability that he chose box X? So we're going to set this out with a tree diagram. So there's 2 sections of this. What we have is his initial spin, and he can get either X, Y or Z. So we're going to write those in, so X, Y or Z. And the probabilities, according to the blurb at the top there, is 0.2, this one is 0.3, and then this one is 0.5. Okay, the next thing we have is he's either going to win or he's going to lose. So I'm going to put W for a win, L for a lose. W for a win, L for a lose, and W for a win, and L for a lose. And there's different probabilities depending on which one he chose. So if we have a look at the X one, it says that there is 1 winning one and 3 losing cards. So 1 out of 4, which is 0.25 for the winning one, which means he has a 0.75 chance of losing. In box Y, it says 3 winning cards and 1 losing card. So this one is 0.75 and this is 0.25. And for the Z box, 2 winning and 3 losing, so that's 2/5, which is 0.4, and this here is 0.6. So just make sure that you're happy where all those probabilities came from, and then we can continue with what it's actually asking us. So let's put into words what's going on. It says, given that Kevin wins 100,000 prize, what's the probability he chose X? If we write that down, it's the probability that he chooses box X, given, here it is, given that he wins, so he wins the 100,000 prize. Okay, so that's what we're trying to work out. So we've got to find the intersection of that over the fact that he wins 100,000. So if we write it as what we're looking for, it's the probability of box X intersection wins 100,000 over the probability, or the number of ways, whatever you want to call it, that he wins 100,000 euro or pounds, whatever. Okay, so let's have a look. The intersection of him getting box X intersection and he wins, so that's X and he wins, so that there is the intersection of this happening, which is 0.2, because when we go across it's 0.2 times 0.25, and if we work that out, that comes out to be 0.05, so that there is 0.05. Okay, and there is the intersection. There's 3 possible ways that he wins 100,000. We have this way, which we've already got, this way, or we have this way. So we need to work out all of those 3 probabilities, this one, and this one, and that'll give us the probability that he wins 100,000. So let's have a look at those now. So we'll do, already got this one, already worked that one out. The second one, which is this one here, is 0.3 times 0.75. If we work that out, what we have is 0.225, I think. And then the last one, which is going from here, and then winning, is 0.5 times 0.4, which is equal to 0.2. Okay, so this is 0.2. So in order to work out these probabilities, we know that this here is just this probability, that's the intersection, it's box X and, or intersected with the fact he's won, and then we're going to divide by this, this and this all added together. So this now looks like 0.05 all over, and what we have then is 0.05 plus 0.225 plus 0.2, and that comes out to be 0.475, which is equal to 2 over 19. Okay, and that's the easiest way to do this question, lads. Nice way of doing it is to use a probability tree.